Today I'm going to talk to you about surface area of rectangular and triangular prisms. So the best thing you can do is to first look at the shape and work out how many faces there are on that shape. So if I draw a basic rectangular prism, I need to look at that and see that there are 6 faces. Once you've worked out how many faces there are, you then need to determine how many of them are the same size as each other. So I'll need to put some dimensions on here. Let's suppose that we have a square face at the front and it's 2 centimetres by 2 centimetres. And along the side we have a rectangular face and that's 10 centimetres in length. So looking at this, I can either imagine what's on the other side of this rectangular prism, or I can draw out a plan view or a net of this shape. So if I draw out a net, I will have 4 of these rectangles that are folded up to make this surface, and then as we've just mentioned, there are squares on the top of either or on either end, and we can put the dimensions that we had on here. Some people will prefer to imagine the shape like this, and some people will prefer to open the shape out. Whatever your option is, the first thing you need to work out though is how many sides or faces are the same size as each other. So looking at here, the opposite faces have to be the same as each other. So you could work out the area of this shape and double your answer. And then knowing that this is a 2 by 10 and so is the one on top 2 by 10, you've got 4 rectangles that are all identical in size. So you would work out the area of this rectangle, 10 by 2, and then you would multiply that answer by 4. So let's do that. So our area of the first rectangle or square is 2 of them multiplied by 2 times 2. Okay, so 2 being how many there are, and obviously the area of that side being 4 gives us 8 centimetres squared. And this one, our second area, well, we said there were 4 of them, and the area of each rectangle is 2 times 10, which is 4 multiplied by 20, which is 80 centimetres squared. That means the total surface area is 80 plus 8, which is 88 centimetres squared. So the total is 88 centimetres squared. Now, that's just been written slightly off the bottom of your screen, but we worked out there were 6 faces. So we just want to confirm that we've got the 6 faces. 2 and 4 makes the 6. All right, so I'm now going to look at a slightly different size rectangular prism. Let's make it so that the front of the rectangle, the face, is a rectangle, not a square this time. So I'll just give it some dimensions. We'll go 2 centimetres and 3 centimetres. And then again, I'll make the length 10, because it's just a nice easy number to work with. So step 1, how many faces are there? Same shape, so we're dealing with 6 faces. Next thing, how many are the same size as each other? So this side and this side opposites are going to be the same size. So we'll call that number 1, and we know there are 2 of those. So area number 1, we know there are 2 of those. And the dimensions of that rectangle are 2 times 3. Okay, we can work that out in a moment. Then we move on to the second rectangle. Let's do this one here on the side. And we know that that is sitting opposite a rectangle that is the same size. So we have 2 of those, and they have dimensions 2 by 10. And then we have a third area, which I'll have to write over here, which is at the top there. That one at the top has the same as the one on the bottom, and that we'll call area 3. And there are 2 of those, and its dimensions are 3 by 10. The total surface area then will be the area of 1 plus 2 plus 3. Okay, and we've already taken into consideration how many of those there are. So let's check we have our 6 faces. 2, 4, 6. Excellent. Let's do the calculations. 2 times 3 is 6. 2 times 6 is 12, and we're centimetres squared. 2 times 10 is 20, and 2 times 20 is 40, so we're 40 centimetres squared. And then over here, 3 times 10 is 30, and we're doubling that, so we have 60 centimetres squared. So adding up all our areas together, 40 and 60, so let's write it down at 12 plus 40 plus the 60 gives us a total area of 112 centimetres squared. All right, let's look at a triangular prism. So I've drawn up 2 triangular prisms, and you really need to work out how many faces there are and how many of them are the same size as each other. So I've drawn 2 totally different triangular prisms. This one, I don't know if you can see the markings on there because of the pen I've used, so I've popped the markings here, but this one has a face with an isosceles triangle on the front here. And so obviously the one on the back is the same size as that one. But the rectangles around the outside have these 2 will be the same size as each other due to these sides being the same size and obviously a common length. However, this base rectangle that the triangular prism is sitting on is not the same size as these 2 because the markings aren't on there. So what we have there is 2 triangles. So if we're talking about the surface area, we've got 2 triangles. So our area 1 consists of 2 triangles and whatever they are, because I haven't given them dimensions. And our second area would be the 2 rectangles that kind of fold to make the roof, I guess, if you think about it that way. There'll be 2 rectangles. And then the final surface, the 5th surface, is that bottom, the base. And there's only one of those, and that's our base rectangle. And then the total surface area would be all those 5 surfaces added together. Now looking over here, we consider this one. There are no markings on this triangle. So technically, there are 5 surfaces, of which the only 2 surfaces that are the same as each other are the cross section, the triangle at the front, I guess, as I'm looking at here, and then obviously opposite. The 3 rectangles that go around the shape are all different sizes. The only thing they have in common is its length. All of the other dimensions are different. And you really need to make sure that you work out how many of them are the same size altogether before you start your calculations. So I suggest making a plan, okay? I'm going to leave it there. Hopefully you've got a bit more understanding of how you can work out the total surface area of some of these basic prisms.